Deep in the frozen darkness of space, a gigantic dark eye is staring into the void and breathing violently. It eats up enough room to swallow our entire planet Earth whole, yet nobody can hear its terrifying roar. Right now, nearly 3 billion miles away from us, this icy giant is reshaping its skin and shifting across a frozen atmosphere. It is hunting through the cold night, hiding secrets that break every rule of weather we have ever known. If you love uncovering the deepest and most mysterious true stories hidden in our universe, hit that subscribe button right now to join our community. We break down real science without any hype, so you will always be the first to know what is truly happening out there. To understand why this massive storm on Neptune is baffling the smartest scientists at NASA, we first have to take a look at where this strange world sits in our solar system. Neptune is the 8th and farthest official planet from our Sun, sitting at a breathtaking distance of roughly 2.8 billion miles away from Earth. That is 30 times farther from the Sun than we are, meaning light from the Sun takes over 4 hours just to reach its frozen atmosphere. Because it receives less than 1% of the sunlight that Earth receives, you might expect Neptune to be a completely dead, frozen, and motionless ball of ice in the dark. But the reality is completely the opposite, as Neptune turns out to be one of the most violent and active weather environments ever discovered in the cosmos. If you were to stand on the upper clouds of Neptune, the Sun would look like nothing more than a bright star in a dark afternoon sky. Temperatures in the outer atmospheric layers drop down to a bone-chilling minus 350 degrees Fahrenheit, which is roughly minus 212 degrees Celsius. At these extreme temperatures, gases like methane freeze into tiny floating ice crystals. Methane gas absorbs red light and reflects bright blue light, which gives Neptune its beautiful and famous deep azure color. It takes Neptune 165 Earth years to complete just one single orbit around the Sun, meaning each of its seasons lasts for over 40 Earth years. Long before humans ever sent robotic spacecraft into the outer solar system, Neptune existed only as a mathematical calculation on a sheet of paper. In the early 19th century, astronomers observed that Uranus was not following the exact path predicted by Isaac Newton's laws of gravity. Something invisible was tugging on Uranus, causing it to speed up and slow down in its orbit around the Sun. Two brilliant mathematicians, Urbain Le Verrier in France and John Couch Adams in England, set out to solve this celestial puzzle independently. They calculated the exact mass, speed, and position of a secret planet that had never been seen by human eyes. In September of the year 1846, German astronomer Johann Galle pointed his telescope at the exact coordinates provided by Le Verrier. Within less than 1 hour of searching, he spotted a tiny blue point of light that was not listed on any star map. Math had successfully revealed a massive new planet sitting in the dark outer reaches of our solar system. And this sensational discovery was hailed as one of the greatest triumphs of theoretical science in human history. Human beings had used pure logic and mathematics to locate a world nearly 3 billion miles away from Earth. For nearly 150 years after its dramatic discovery, astronomers knew very little about what Neptune actually looked like up close. Telescopes on Earth could only see Neptune as a small, featureless blue marble floating in the vast ocean of space. Because Earth's thick atmosphere distorts incoming light, ground-based instruments could not reveal any weather patterns, clouds, or surface details on Neptune. Many scientists assumed that because Neptune was so far from the warm rays of the Sun, its atmosphere would be completely still, quiet, and unchanging for thousands of years. That all changed in August of the year 1989, when NASA sent a robotic probe called Voyager 2 on a daring flyby past the planet. Voyager 2 had been traveling through space for 12 long years to reach Neptune, making it the first and only spacecraft ever to visit this mysterious outer world up close. The pictures sent back across billions of miles of space shocked planetary scientists and instantly rewrote our understanding of the outer solar system. When Voyager 2 zoomed past Neptune at over 40,000 miles per hour, its cameras captured something completely unexpected sitting right in the middle of the southern hemisphere. There, etched into the bright blue clouds, was a dark, oval-shaped monster storm that scientists immediately named the Great Dark Spot. This single storm measured roughly 8,000 miles long and 4,000 miles wide, making it nearly identical in size to our entire home planet Earth. It looked like a giant dark wound torn open on the face of the planet, surrounded by white, wispy clouds that drifted around its edges like smoke. What made this discovery even more terrifying was the sheer speed of the winds surrounding the storm. Scientists analyzed the movement of the clouds and calculated that winds around the Great Dark Spot were blowing at over 1,300 miles per hour, which is roughly 2,100 kilometers per hour. To put that insane number into perspective, the strongest Category 5 hurricanes on Earth rarely feature sustained winds over 157 miles per hour. That means the winds on Neptune were blowing more than 8 times faster than the most destructive hurricanes ever recorded in human history. In fact, these are the fastest atmospheric winds ever measured anywhere in our entire solar system. Scientists originally thought that Neptune would be a calm and quiet world because it sits so far away from the heat of the Sun. They expected the atmosphere to be slow and sluggish, moving like thick syrup in the freezing cold, but finding a hurricane the size of Earth spinning with supersonic winds blew those old theories completely out of the water. Researchers realized that Neptune had a secret power source hiding deep down inside its core that was driving these unbelievable weather patterns. This massive gap between what experts expected and what they actually found marked the beginning of a decades-long cosmic mystery that continues to puzzle astronomers today. Have you ever wondered what it would be like to see a storm on another world that blows 8 times faster than Earth's worst hurricanes? If that fact amazed you, drop a quick comment below with your thoughts and smash that like button so more space fans can discover this incredible story. After the astonishing success of Voyager 2 in 1989, astronomers were eager to keep a continuous eye on this giant dark hurricane on Neptune. However, Voyager 2 was a flyby mission, meaning it flew past Neptune and kept traveling out into interstellar space, never to return. Scientists had to wait 5 long years until the Hubble Space Telescope was launched and repaired, with high-resolution cameras capable of seeing distant planets clearly from Earth orbit. In 1994, NASA astronomers pointed Hubble directly at Neptune, fully expecting to see the Great Dark Spot still spinning in the southern hemisphere, just like Jupiter's famous Great Red Spot has been spinning for hundreds of years. Here's the exact moment that left space researchers completely speechless when the pictures were processed. When the new Hubble images came back to Earth, the Great Dark Spot was gone. It had not just shrunk or faded slightly, it had completely vanished without leaving a single trace behind. A storm that was large enough to engulf our entire planet, with winds flying at supersonic speeds, had simply dissolved into thin air in less than 5 years. Planetary scientists were utterly stunned because nothing like this had ever been observed on gas giants like Jupiter. This sudden disappearance created a massive puzzle for researchers who thought large planetary storms were permanent features. On Jupiter, the Great Red Spot has been raging for at least 350 years because there are no solid surfaces or mountain ranges to slow down the winds. Scientists assumed Neptune's Great Dark Spot would behave the same way and last for centuries. Finding out that a planet-sized storm could form, rage violently, and completely disintegrate in just a few short years forced meteorologists to realize that Neptune's atmosphere works on entirely different rules than any planet we know. The mystery only grew deeper just 1 year later in 1995, when astronomers pointed Hubble at Neptune once again. They discovered that a brand new dark spot had suddenly appeared on the planet, but this time it was located in the northern hemisphere instead of the southern hemisphere. This new storm was almost identical in size and shape to the original Great Dark Spot found by Voyager 2. It became clear that Neptune does not have one eternal storm, but rather a repeating cycle where monster storms are born, float across the planet, and then vanish into the atmosphere every few years. Scientists began asking fundamental questions about how these dark spots actually form in the first place. When you look at a dark spot on Neptune, you are not actually looking at a dark cloud sitting on top of the atmosphere. Instead, research suggests that these dark spots are gigantic holes or clearings torn into the upper methane cloud layer. Think of it like a massive hole in the fog above a city, allowing us to peek deeper down into the darker, lower atmospheric layers beneath. Surrounding these dark holes are bright white clouds made of frozen methane ice crystals that form when gas is forced upward and freezes instantly in the upper atmosphere. To make sense of these disappearing storms, computer simulations were created by teams of atmospheric researchers at institutions like NASA's Jet Propulsion Laboratory and various universities. These computer models showed that the dark spots are actually massive high-pressure systems called anticyclones, which spin in a direction opposite to low-pressure hurricanes on Earth. As these giant vortexes drift slowly toward the equator of Neptune, the planet's changing wind patterns begin to squeeze and stretch them. Eventually, when the storm gets too close to the equator, the powerful jet streams tear the vortex apart, causing the dark spot to break down and completely vanish from sight. Does the idea of a planet-sized storm completely vanishing in just a few years sound impossible to you? Let us know in the comments if you think humanity will ever build a probe that can fly right into one of these storms, and subscribe right now so you never miss our next space deep dive. For many years, scientists could only catch glimpses of these dark spots after they had already fully formed and grown to planet-sized proportions. They were always looking at the finished product, which made it almost impossible to figure out what triggers the birth of a monster storm in the first place. And that all changed in the year 2018 when the Hubble Space Telescope captured a series of images that gave NASA scientists their very first front row seat to the actual birth of a great dark spot. This discovery provided a crucial piece of the puzzle that researchers had been hunting for nearly 30 years. When NASA astronomers analyzed archival pictures taken by Hubble between 2015 and 2017, they noticed small, bright white companion clouds forming in Neptune's northern hemisphere long before any dark spot was visible. These bright clouds were made of methane ice crystals floating at extremely high altitudes generated by deep air currents pushed upward. Then, in 2018, a massive dark spot measuring over 4,000 miles across suddenly emerged right under those exact same white clouds. This proved beyond a shadow of a doubt that these storms do not start on the visible surface of Neptune. They are born deep down in the hidden depths of the atmosphere years before we can ever see them. This discovery highlighted a huge gap in human knowledge regarding what lies beneath the top cloud decks of ice giants. On Earth, weather is heavily influenced by the solid rocky ground, oceans, and sunlight heating the surface. But Neptune has no solid surface at all. It is composed of a thick outer atmosphere of hydrogen, helium, and methane that gradually transitions into a hot, dense liquid mantle of water, ammonia, and methane ice surrounding a small rocky core. The fact that dark spots take years to bubble up from the deep interior means that powerful atmospheric engines are running deep inside the planet, far below where any optical telescope can see. To understand what is happening inside Neptune, scientists have to study the extreme pressure and heat hidden deep beneath those blue clouds. Deep inside the planet, pressure increases to millions of times greater than the air pressure on Earth. Under these crushing conditions, methane gas gets squeezed so hard that carbon atoms separate from hydrogen atoms and crystallize into real diamonds. Scientists believe that literal diamond rain falls through the liquid ocean mantle toward Neptune's core, releasing gravitational energy and creating massive heat currents that drive weather patterns near the surface. The existence of diamond rain inside ice giants was once considered pure science fiction, but recent experiments in high-energy laser laboratories have proven that it is scientifically real. Researchers at the SLAC National Accelerator Laboratory use powerful X-ray lasers to shock plastic compounds made of hydrogen and carbon, simulating the crushing pressures found 5,000 miles inside Neptune. In a fraction of a second, the laser pulses squeeze the atoms together, creating microscopic real diamonds right inside the laboratory chamber. This experiment proved that deep inside Neptune, vast hailstorms of pure diamond are constantly raining down through thousands of miles of hot liquid mantle. As these heavy diamond hailstones fall toward the planetary core, they frictionally heat the surrounding liquid fluids, transferring massive amounts of thermal energy from the core outward into the lower atmosphere. This continuous diamond rain cycle provides a steady stream of internal energy, acting like an engine fuel that powers the planet's atmospheric currents. Without this internal heating mechanism driven by falling diamonds, Neptune would be as cold, quiet, and motionless as scientists originally predicted back in the 19th century. The mystery took an even bigger leap forward when the James Webb Space Telescope, or JWST, turned its revolutionary infrared eyes toward Neptune in July of 2022. JWST is the most powerful space telescope ever built by humanity, stationed roughly 1 million miles away from Earth. While Hubble sees the universe primarily in visible light, JWST views the cosmos in near-infrared light, which senses heat and invisible wavelengths of light that pass right through cosmic dust and hazy atmospheres. When the first JWST images of Neptune were processed and released to the public, scientists were completely blown away by what they saw. Instead of the familiar deep blue marble captured by Voyager 2 and Hubble, Neptune appeared in the JWST images as a glowing, ghostly white world wrapped in sharp, delicate rings that had not been seen clearly in over 30 years. Because methane gas strongly absorbs infrared light, the deep, calm parts of Neptune's atmosphere appeared dark in the JWST camera, but high-altitude clouds and massive storm systems reflected infrared sunlight brilliantly, glowing like bright neon flares across the disk of the planet. These infrared images revealed an intricate network of massive storm systems wrapping around the planet's equator in high-latitude regions with unprecedented detail. What makes these JWST observations so critical is that they allow scientists to map the three-dimensional structure of Neptune's atmosphere for the very first time. By looking at different infrared wavelengths, researchers can peer through different atmospheric depth layers, measuring temperature changes and gas movements from the freezing upper stratosphere down into the crushing depths of the troposphere. The data revealed that giant bright clouds near the equator are tied to massive upwelling thermal plumes, meaning hot gas from the deep interior is bursting upward like a cosmic geyser, feeding energy into these giant storm systems. Would you have ever guessed that Neptune looks like a glowing white jewel when viewed through infrared light? Tell us in the comments what you think of these stunning James Webb images, and give this video a like to show your support for space exploration. Now, here is the detail that people remember most when they study the physics of Neptune, because it seems to completely break the laws of common sense. Neptune is located nearly 3 billion miles from the Sun, receiving roughly 0.1% of the solar energy that falls on Earth. On Earth, sunlight is the primary engine that drives all weather, heating the equator, creating wind currents, and powering giant hurricanes. By all logical rules of physics, a world that receives almost no solar energy should have the weakest, calmest winds in the solar system. Yet, as we know, Neptune boasts the most violent supersonic winds ever recorded on any planet. How is it possible for a world floating in the freezing cosmic dark to produce winds over 1,300 miles per hour? The secret lies in a mind-blowing fact that scientists discovered by measuring the heat radiating off the planet into space. Neptune actually generates more than double the amount of heat that it receives from the Sun. Specifically, it emits roughly 2.6 times as much energy as it absorbs from solar radiation. That means Neptune has a powerful, fiery internal furnace deep within its core that is constantly pumping heat outward into its freezing upper atmosphere. Scientists believe this internal heat is left over from the formation of the planet 4.5 billion years ago, combined with the decay of radioactive elements and the slow sinking of heavier materials toward its center. As this intense heat travels outward from the core through thousands of miles of high-pressure fluid, it creates massive convection currents, similar to boiling water in a pot on your stove. Hot fluid rises toward the surface, while cold fluid sinks back down into the depths. This endless circulation of heat from within, combined with the rapid 16-hour rotation speed of Neptune, creates smooth, low-friction wind channels that accelerate atmospheric currents to supersonic speeds. To make things even more fascinating, Neptune's neighbor planet, Uranus, is almost the exact same size, mass, and temperature as Neptune, yet Uranus generates almost no internal heat and has a remarkably quiet, featureless atmosphere. This stark contrast between twin planets is one of the greatest unsolved mysteries in modern astronomy. Why does Neptune possess a raging internal heat engine that spawns storms bigger than Earth, while Uranus sits relatively quiet and cold? Researchers suspect that a catastrophic collision early in the history of Uranus may have knocked the planet on its side and knocked out its internal heat structure, whereas Neptune retained its violent interior core intact. The internal heat of Neptune also causes dramatic seasonal changes that take place over decades. Because Neptune takes 165 Earth years to go around the Sun, each season on Neptune lasts for about 40 Earth years. Scientists tracking Neptune's temperature with ground-based infrared telescopes noticed that as southern summer began, the planet slowly warmed up, but then suddenly experienced a puzzling cooling trend across most of the planet between 24 and 2020. Temperatures dropped by as much as 8 degrees Celsius in just a few years, showing that Neptune's global climate is much more volatile and unpredictable than anyone originally imagined. At the exact same time that the rest of the planet was cooling down, Neptune's south pole experienced an unexpected and dramatic warm spot, heating up by 11 degrees Celsius in a matter of just 2 years. This sudden polar warming created massive thermal updrafts that triggered bright methane cloud storms right over the pole. Astronomers are currently struggling to explain how a planet can cool down globally while its pole suddenly spikes in heat, suspecting that complex chemical interactions between sunlight and atmospheric methane gas might be altering heat absorption in the upper stratosphere. Another surprising piece of the Neptune puzzle is how the planet's atmospheric weather interacts with solar magnetic activity billions of miles away. In 2023, astronomers analyzed 30 years of observations from the Hubble Space Telescope and discovered a shocking link between Neptune's clouds and the Sun's 11-year solar cycle. When the Sun reaches its peak magnetic activity known as solar maximum, it blasts out intense bursts of ultraviolet light across the solar system. Within 2 years of a solar maximum, bright methane clouds on Neptune experience a dramatic population explosion covering large portions of the planet's disk. Conversely, when the Sun enters solar minimum and ultraviolet radiation drops, the bright clouds on Neptune fade away and completely disappear within 2 years. Scientists realized that high-energy ultraviolet rays from the Sun travel nearly 3 billion miles to strike Neptune's upper atmosphere, breaking down methane molecules through a process called photochemistry. This chemical reaction triggers the condensation of methane ice crystals at high altitudes, producing the brilliant white clouds that sit above dark spots. This discovery proved that even at the extreme edge of the solar system, planetary weather is intimately connected to the beating heart of our Sun. As scientists continue to analyze data from Hubble and JWST, the story of Neptune has shifted from a historical discovery into a live, ongoing scientific investigation that is happening right now. Today, astronomers use automated planetary tracking programs to keep a continuous eye on Neptune's atmosphere because the weather on this distant ice giant is changing faster than ever observed before. In late 2020, Hubble caught a massive dark spot doing something that planetary scientists had never seen in 3 decades of observation. The storm, which was roughly 4,000 miles across and sitting in the northern hemisphere, began drifting southward toward the equator, following the exact path that usually leads to a storm's death. Scientists watched closely, expecting the storm to get torn apart by equatorial winds and disappear forever, just like all the others before it. But then, in a completely shocking twist, the dark spot suddenly stopped its southward drift, executed an impossible U-turn, and began drifting back north toward the polar region. At the exact same time, a smaller companion dark spot, nicknamed Dark Spot Jr., split off from the main storm, floated toward the equator, and vanished on its own. How wild is it that a planet-sized storm could do a full U-turn in midair instead of dying at the equator? Drop your favorite theory in the comments section below and hit subscribe right now so you can stay updated on all the latest space discoveries as they happen. This unprecedented U-turn showed that scientists are far from fully understanding the atmospheric dynamics of ice giant planets. Right now, in the present day, teams of international researchers are running complex fluid dynamics simulations on supercomputers to model how a planet-sized vortex can reverse its direction in midair. They suspect that a subtle shift in deep wind patterns or a sudden injection of thermal energy from the planet's interior may have pushed the storm back north, extending its lifespan far beyond what anyone thought possible. This proves that Neptune is an active, unpredictable laboratory for fluid physics that continues to surprise us every single year. In March of 2025, the James Webb Space Telescope delivered yet another groundbreaking discovery that added an entirely new dimension to Neptune's atmospheric story. Using its high-precision near-infrared spectrograph, Webb captured the very first confirmed images of bright auroral glows on Neptune. Auroras occur when charged particles streaming from the sun get trapped in a planet's magnetic field and slam into the upper atmosphere, creating a dazzling light show. On Earth, Jupiter, and Saturn, auroras are confined tightly around the northern and southern poles, but on Neptune, Webb revealed that the auroras were glowing at middle latitudes, right around where South America would sit on Earth. This strange location is caused by Neptune's extremely weird magnetic field, which was first discovered by Voyager 2 back in 1989. Neptune's magnetic field is tilted by a staggering 47 degrees relative to its rotation axis and is offset from the center of the planet by thousands of miles. When solar particles hit this tilted magnetic field, they are funneled into the atmosphere far away from the poles. Webb's measurements also revealed that Neptune's upper atmosphere has cooled by several hundred degrees since Voyager 2 visited in 1989, proving that even the highest layers of this freezing world undergo dramatic long-term climate changes. To make things even stranger, the magnetic field of Neptune is not generated in a central iron core like Earth's magnetic field. Because Neptune lacks a solid metal core, scientists believe its magnetic field is generated in an electrical mantle layer located just beneath the upper cloud decks. In this region, liquid water, ammonia, and methane are compressed into a superionic fluid, where hydrogen ions move freely through a solid crystal lattice of oxygen. Electric currents flowing through this churning superionic shell create an unstable, lopsided magnetic field that wobbles wildly as the planet rotates every 16 hours. This chaotic magnetic field creates massive space weather storms around Neptune, accelerating energetic electrons to tremendous speeds before slamming them into the planet's mid-latitude clouds. As these high-energy electrons collide with atmospheric methane and hydrogen gas, they illuminate the sky with bright ultraviolet and infrared auroral displays. The combination of lopsided magnetic fields, diamond rain convection, and supersonic jet streams makes Neptune one of the most electromagnetically intense planet environments in our solar system. Another key piece of the Neptune mystery lies in its bizarre moon system, particularly its giant moon Triton. Triton is the largest of Neptune's 14 known moons, measuring about 1,600 miles in diameter, making it nearly as large as Earth's moon. But Triton is completely unique among major moons in our solar system because it orbits Neptune in a retrograde direction, meaning it spins opposite to the planet's rotation. This strange orbit proves that Triton was not formed alongside Neptune. It was originally an icy dwarf planet floating in the outer Kuiper belt that was captured by Neptune's massive gravitational pull billions of years ago. When Triton was violently captured by Neptune's gravity, its gravitational pull tore through Neptune's original moon system, destroying older moons and creating immense tidal friction. This gravitational tug-of-war pumped massive amounts of heat into Neptune's interior, potentially melting deep ice layers and churning up its core. And even today, Triton exerts a subtle gravitational pull on Neptune's atmosphere, creating high-altitude tidal bulges that may influence how deep atmospheric currents move. Triton itself is an active world with geysers shooting frozen nitrogen gas miles into space, showing that the entire Neptune system is alive with heat and activity. Do you think Triton's violent capture billions of years ago could be the main reason Neptune's internal furnace is still burning so hot today? Write your answer in the comments below and share your thoughts with our growing community of passionate stargazers. Scientists also suspect that Triton's gravitational drag is gradually slowing down Neptune's atmospheric rotation in subtle ways over geological timescales. As Triton orbits in reverse, its tidal interaction with Neptune creates a continuous drag force that strips away rotational momentum from the upper atmosphere. And this friction creates massive shear zones where deep jet streams collide with upper atmospheric layers, generating intense turbulence that can trigger the birth of new dark spot vortexes. The relationship between Triton and Neptune shows that even distant icy moons can actively shape the weather of giant planets. Furthermore, Triton's presence offers a rare glimpse into the distant past of the Kuiper belt, the icy region of space beyond Neptune that holds Pluto and thousands of other icy bodies. Triton is essentially a preserved relic from the early solar system, wrapped in a mantle of frozen nitrogen, water ice, and carbon dioxide. Scientists believe that beneath Triton's icy crust lies a hidden liquid water ocean kept warm by radioactive heating and orbital tidal forces. If life could exist in the subsurface ocean of Triton while monster storms rage on Neptune nearby, it would completely change our understanding of where living organisms can survive in the cosmos. Understanding the massive storms and weird magnetic fields on Neptune is not just an academic exercise for scientists who study our own solar system. It has massive implications for our search for life and habitable worlds across the galaxy. Over the past 20 years, NASA's Kepler Space Telescope and the Transiting Exoplanet Survey satellite have discovered thousands of planets orbiting distant stars outside our solar system. The single most common type of planet found in our galaxy turns out to be planets that are between the size of Earth and Neptune, often called mini-Neptunes or sub-Neptunes. Because we do not have any sub-Neptune planets in our own immediate solar system, Neptune itself is the closest, best natural laboratory we have to study how these middleweight planets operate. By uncovering how heat moves through Neptune's atmosphere, how methane clouds interact with deep, high-pressure systems, and how monster storms form and vanish, scientists are gaining vital blueprints to interpret data from exoplanet atmospheres billions of light years away. Every new discovery made by Hubble and JWST on Neptune helps astronomers decode the weather, chemistry, and potential habitability of alien worlds floating around distant stars. Many of these exoplanets orbit much closer to their host stars than Neptune does to our Sun, creating extreme environments where internal heat and intense stellar radiation collide. If a storm on Neptune can generate supersonic winds driven mostly by internal energy, imagine what weather looks like on a hot sub-Neptune world bathed in intense stellar heat. Studying Neptune allows scientists to refine computer climate models, ensuring that when space telescopes scan distant exoplanets for biosignatures or atmospheric gas compositions, researchers can accurately distinguish between natural storm chemistry and potential signs of alien life. Because Neptune is so far away, humanity has only sent a single spacecraft to visit it for a few brief hours back in 1989. That is why planetary scientists around the world are currently urging space agencies like NASA and the European Space Agency to prioritize a flagship orbiter mission to the ice giants in the coming decades. Proposed mission concepts, such as the Neptune Odyssey orbiter, would launch in the 1930s or 1940s, spending several years orbiting Neptune to map its atmosphere, drop a probe into its cloud decks, and explore the icy ocean surface of Triton up close. A dedicated orbiter mission would revolutionize our understanding of planetary physics in ways that distant space telescopes simply cannot match. By dropping an atmospheric probe directly into Neptune's clouds, scientists could measure the exact chemical makeup, pressure gradients, and wind speeds at depth levels never seen before. Such a mission could finally solve the mystery of where Neptune's internal heat comes from, confirm whether diamond rain actually falls through its mantle, and observe the birth and death of dark spots from right inside the storm clouds themselves. Until a new spacecraft arrives at Neptune, astronomers will continue relying on powerful observatories like the James Webb Space Telescope and next-generation ground telescopes like the extremely large telescope currently being built in Chile. With advanced adaptive optics capable of canceling out Earth's atmospheric blur, these new giant ground observatories will monitor Neptune with even higher clarity than Hubble, tracking short-term weather changes, cloud formation, and vortex movements on a weekly basis. When you zoom out and look at the bigger picture, the giant dark storms on Neptune remind us of how dynamic, interconnected, and fragile planetary atmospheres really are. Our own home planet Earth relies on a delicate balance of solar radiation, ocean currents, and atmospheric pressure to maintain a stable climate that supports human life. Studying the extreme, chaotic, and supersonic weather systems on worlds like Neptune gives scientists a deeper, more comprehensive understanding of fluid dynamics and climate physics as a whole, helping us better protect and appreciate the precious blue marble we call home. Looking up at the night sky, it is mind-boggling to realize that nearly 3 billion miles away, a dark storm larger than our entire planet is raging right now through icy methane clouds at supersonic speeds in complete silence. We live in an incredible era of human history where space telescopes sitting millions of miles from Earth can snap clear images of these distant cosmic leviathans, letting us watch alien weather unfold in real time. As technology advances and future space missions are designed to send new robotic orbiters back to the ice giants, the mysteries of Neptune will continue to inspire human curiosity for generations to come. If you enjoyed this deep dive into the hidden secrets of Neptune, please hit that subscribe button right now, turn on all notifications so you never miss a new video, drop a comment telling us what space mystery we should cover next, and share this video with anyone who loves space. Thank you so much for watching, and keep looking up at the stars.